Hello, welcome back to my channel. Today we are going to do revision for BSPM set 1. So you can click on the link below. I already sent the link attached in the pin message. We'll continue with the discussion for the multiple choice for Pre-Pspm set 1. Okay, so questions number 1. The symbol of the dimension of the mass length and the time is MLT respectively. What are the dimensions for power? Okay, so we know that power is equal to the rate of the work done. Okay, so work done, dimension for work done is equal to ml2 t negative 2, and the time is capital T. Therefore, the dimension for power is equal to ml squared t negative 3. So the answer is C. Okay, question number 2. A car is moving with 110 km per hour. What is the speed in meter per second? So we need to change it into meter per second. Okay, so V equals to 110 kilo. We need to convert into meter. So times exponent positive 3, and 1 hour is equal to 60 minutes times 60 seconds. Okay, so the answer that we will get is equal to 30.6 meter per second. So the answer for question number 2 is B. Question number 3. A ball is fired 30 degrees to the horizontal with a speed of 100 meters per second. Calculate the horizontal range. The horizontal range actually is xx. Okay, the ball is fired 30 degrees to the horizontal. Okay, after that it will go to the maximum and reach the ground. Okay, at the initial velocity 100 meters per second. So now we want to find the horizontal range sx, and we know that xx is always equals to uxt. Okay, so ux we know because we have 100 cos 30 degrees, but the time taken for the ball to reach the ground we don't have, so we need to use y component. We need to find the t from y component. Okay, so what are the information we have? Okay, the first one is y, uy, where uy we have 100 sine 30 degrees, and we have acceleration 9.81. Okay, and also we have the displacement because it's from ground fire and then go to the maximum point and then go back to the ground. Okay, so meaning that the displacement is actually equals 0. Okay, so we can use s equals to ut minus half gt squared to find out the time taken. Okay, so the displacement, we substitute 0. U is 100 sine 30 degree times t minus half, g is 9.81 t squared. Okay, so the time taken, we will get 10.19 seconds. After that, you substitute into the equation sx equals to ust. Okay, you substitute 10.19. Therefore, the horizontal range or the sx, the value that we will get is equals to 883 meters. So the answer is donkey. Okay, question number 4. So this is the VT graph of the linear motion showing in a joint figure. The distance from the original after 8 seconds. Okay, so here we have two parts. Part A is above, part B is at the bottom. Okay, so we need to find the distance. Distance meaning that we only consider the magnitude. Okay, so area under graph. Okay, we know that distance is equal to area under graph. Okay, area under VT graph. Okay, so for part A, the distance for A is equal to 1/2 because it's trapezium. So it's 1/2, 4 plus 2 times 4. Okay, so the distance for part A is equal to 12 meters. For part B, it's also a trapezium. So we take half, 2 plus 4, okay, here is 4, times the value of negative 2. Okay, therefore, the value that we will get is negative 6 meters. Okay, so negative 6 here actually shows the direction is in opposite direction, meaning it's to the left. But the question asks us to find the distance. The distance meaning that we don't need to consider the direction. We just take the total distance traveled. So therefore, the total distance traveled is equal to 12 plus 6. So the answer is 16. Okay, so if the question asks displacement, if let's say asks displacement, it would be 6 meters. Okay, but now the question asks us to find the distance. So the answer is boy. Next question is number 5. A 7-gram bullet moving with initial velocity 100 meters per second strikes a wooden block. The bullet undergoes uniform deceleration and stops after 15 cm inside the block. Okay, calculate the average force experienced by the block. Okay, so now the information that we have here is only we have the bullet. Okay, so now we can find the information related to bullet. Initial velocity is 100, s is 0.15. Okay, we convert into meter, and then V is equals to 0 because after that it will stop. After it strikes the wooden block, it will stop. Okay, so we need to find the acceleration. Okay, so now we have U, S, V, and we want to find acceleration. We can use the equation V squared equals to U squared plus 2AS, where U, the final velocity, is equals to 0. U is 100 squared plus 2AS, 0.15. So finally, we will get acceleration is equals to negative 3.3 exponent positive 4 meter per second squared. Okay, so negative here shows that it experienced deceleration. Okay, so now we want to find the average force, where force is equal to MA, where M for the bullet is 7 grams. Okay, so it's 0.007 times the acceleration, 3.33 exponent positive 4. Therefore, the force exerted, okay, now negative, okay, the force exerted is equal to negative 223.33 Newton. This is the force exerted on the bullet. Okay, so we know that when there is an action, there will be a reaction. Okay, so if let's say this is the force experienced by the bullet, okay, therefore the force experienced by the block will equal to positive 223.33 Newton. Okay, because there is a action and reaction, they have the same magnitude but in opposite direction. So the answer is donkey. Question number 6. A bullet of 10 grams shoot a stationary block 1.99 kg with the velocity 300. After the collision, the bullet is embedded into or inside the block. So determine the final velocity after the bullet is embedded into the block. Okay, so this is actually, we can use conservations of momentum to find the answer. So M1 U1 plus M2 U2 is equal to M1 plus M2 V. Okay, so M1 is the initial for the bullet is equal to 10 grams, so it's 0.01, moving with 300 meters per second. And initially the block is not moving, so it's equal to 0. Okay, after the collision, bullet 0.01 plus the block 1.99 are moving with the same velocity. So we need to find what is the final velocity. Okay, so here is equal to 3 and 3 is equal to 2V, therefore V is equal to 3 over 2 is equal to 1.5 meter per second. Okay, so the answer is A. Questions number 7. Figure 1 shows 490 Newton force act on a stationary 21 kg box, okay, lying on a rough surface. After 4 seconds, the speed of the box is 3.5 meters per second. Calculate the frictional force on the box. Okay, so this is the questions related to forces. Okay, where we have F external, where is equals to 490 Newton. Okay, so at the same time, it experiences a frictional force. We also have mg and also normal force. So now we want to find frictional force. We can use Fx equals to ma. Okay, so Fx here, okay, if we draw the free body diagram where we have normal force, we have mg, we have frictional force, and also we have F external at the angle of 35 degrees to the horizontal. Okay, so force that involved in the x component is actually Fx external cos 35 minus friction equals to ma. Okay, so we need to find out what is the acceleration first, where we have initially is at rest, so u is equal to 0, and after 4 seconds, okay, after 4 seconds, it will move with the velocity 3.5. Therefore, the acceleration is v minus u over time taken, so it's 3.5 minus 0 over 4. Therefore, the accelerations that we will get is equal to 0.875 meter per second squared. Okay, so we can find the frictional force, where the frictional force is equal to F external 490 cos 35 minus MA, where M is 31 kg, A is 0.875 meter per second squared. Okay, so the final answer that we will get for the frictional force is equal to 374.3 Newton. Okay, so the answer is donkey. Okay, next questions number 8. An object of mass 2 kg is placed 20 cm directly above the top end of the vertical spring. So the spring constant K is 2000. Determine the maximum compression of X. Okay, so this is the initial before compressing, before it release. After it release, okay, this block, it will compress the spring. Okay, it will compress the spring by X. So this is the maximum compression. Okay, so at that moment, there is only elastic potential energy. Okay, so initially we have mgh. Okay, because initially there is only gravitational potential energy. After that, when it releases and it hits the spring, it will compress the spring by x. Okay, so at that moment we only have elastic potential energy. Okay, so based on the conservations of energy, E initial must equal to the total final energy. So initial we have mgh, where the h here, of course, okay, we must refer from the top until the end, okay, from the initial point. So our h here is actually 0.2 plus here, okay, this is the x, okay, where the point it compressed, and is equals to half kx squared. Okay, x is the maximum displacement it can compress. Okay, so we substitute into the equation. M is 2, G is 9.81, 0.2 plus x equals to half, K is 2000, x squared. Okay, so if we expand it, we will get 3.924 plus 19.62x equals to 1000x squared. Okay, so if we arrange back the equation, 1000x squared minus 19.92x minus 3.924 equals to 0. Okay, therefore x, or the value or the maximum compression that we will get, is equals to 0.0732 meter. Okay, so this is answer for questions number 8, and the answer is equals to C. Okay, next question, questions number 9. A stationary car, initially U is 0, with the mass 1000 kg, start to accelerate constant rate. It reaches the speed of 10 meters per second in 8 seconds. Determine the average power produced by the car. Okay, so power is equals to work done over dt. Okay, or actually we can write as work done also equals to change of kinetic energy over change of t. Okay, so change of kinetic energy, we can use half mv squared minus half mu squared over time taken. So we substitute into the equation. Half m is 1000, and then v is 8 squared. Initially u is equals to 0 because it's stationary, over time taken in 8 seconds. Therefore, the average power produced by the car is equals to 6250 watt. Okay, so the answer is actually equals to A. Okay, questions number 10. Sheila has just arrived at the airport and is dragging her suitcase to the luggage check-in desk. She pulls on the strap with the force of 190 Newton at the angle of 35 degrees to the horizontal to displace it in 45 meters to the desk. Okay, determine the work done by Sheila on the suitcase. Okay, so meaning that we want to find the work done. Okay, so the work done equation is equals to Fs cos theta, where F we have 190 Newton, S is 45, cos the angle is 35 degrees. Okay, so the answer we will get is equals to 7003.7 joule. Okay, so the answer is equals to A. Questions number 11. The student carries a bag with the mass of 5 kg from the ground to his class on the first floor, 2 meter high. Find the work done by the boy. Okay, so the work done is equals to force times displacement cos theta. Okay, so actually the force here we are referring to mg, and the displacement here actually is referring to the height. Okay, so therefore actually the work done is equals to the potential energy. Okay, so m is 5 kg times 9.81 times the height 2 meter. Therefore the answer is equals to 98.1 joule. Okay, the answer is A. Questions number 12. A Ferris wheel with the diameter. Okay, so we need to find the radius because later we want to use the radius, the value for radius, not the diameter. And with the rate of 4 revolutions per minute, here they give you the value for omega, where it's equals to 4 revolutions, so we times 2 pi per 60 seconds. Okay, calculate the accelerations of the rider on this wheel. Okay, so acceleration or the centripetal acceleration is equals to v squared over r, or r omega squared, or equals to v omega. Okay, so since we have r and omega, so therefore we use AC is equals to r omega squared, where the radius is equals to 9, and omega is equals to 8 pi over 60 squared. Okay, so if you press calculator, the final answer that we will get is equals to 1.58 meter per second squared. So the answer is donkey. Next, we go to questions number 13. At what altitude from the surface of the Earth will the gravitational field strength be reduced by 10%? Okay, and the mass of the Earth is given 6 exponent 24, the radius is 6.4 exponent positive 6, and the gravitational acceleration is equal to 9.81. So we know that when we are at the radius or at the surface, okay, at R, our gravitational acceleration is equal to 9.81. Okay, so we want to find at what altitude, or we want to find the value for h, where at that moment gravitational acceleration is equal to 0.9 or reduced by 10%. So reduced by 10% is actually 0.9 times 9.81. Okay, so we want to find what is the value for h, the altitude. Okay, so acceleration equation is equal to gm over r. Okay, where the new acceleration is equal to 0.9 times 9.81 equals to 6.67 exponent negative 11, and the mass of the Earth is equal to 6 exponent 24 kg over the radius. Okay, so the radius, of course, we must take r plus h. Okay, so it's r plus h, where r here is the radius of the Earth. So we must substitute 6.4. Okay, so I will substitute 6.4, this one. Okay, 6.4 exponent positive 6. And remember, square. Okay, remember to square. So finally, the altitude is equals to 333 kilometer. Answer is A. Questions number 14. The mass and the radius of the Earth is 6 exponent 24 and 6,400 kilometer respectively. Calculate the period of revolution of a satellite that is 200 km above the Earth's surface. So here, this is the satellite, and the satellite is at 200 kilometer above the surface. Okay, so our period for the satellite is equal to 2 pi square root r cubed over gm. Okay, so r cubed, r here, of course, we must take from the center of the planet. Okay, so meaning that our r here is equal to the radius of the Earth plus the altitude. Okay, where is equals to 6,400 kilo plus 200 kilo. Okay, so the radius from the center of the planet is equal to 6,600 exponent positive 3. Okay, so 6600. And remember power of 3. Okay, g is constant, 6.67 times exponent negative 11. And mass here we are referring is the mass of the planet, not the mass of the satellite. Okay, so the mass of the planet here is the Earth. So it's 6 times exponent 24. Okay, so the final answer for the period is 5,325 seconds. So the answer is A. Okay, questions number 15. A particle is in simple harmonic motion with the amplitude 0.5, the period is 0.4 pi. When t equals to 0 second, the displacement of the particle from the equilibrium position is 0.5, meaning that this particle does not start from the equilibrium position, it starts from the amplitude. Okay, so since it starts from amplitude, so our equation we should write as x equals to a cos omega t, because it starts from amplitude. Okay, so we substitute a is the amplitude 0.5 cos omega t. Okay, omega is equals to 2 pi over period, where the period is equals to 0.4 pi. Okay, so pi and pi we can cancel. Finally, the equation for the displacement is equals to 0.5 cos 5t. Okay, so the answer is equals to C. Next, we go to questions number 16. So questions number 16 is chapter 9 as well, simple harmonic motion, where they give you x in cm, t is in second, and the equation is x equals to 10 sine 20t. Okay, actually this one should be in cm. Okay, determine the amplitude. Okay, so from the equation x equals to a sine omega t, we know that actually 10 is the amplitude. Okay, so here because the question mentions x in cm, so the answer here is 10 cm. Okay, so you must refer back what is the unit. Okay, next question is number 17. A particle of the mass 4 kg moves with a simple harmonic motion and its potential energy varies with the position. So determine the potential energy at the amplitude. So from here, the amplitude is actually 0.2, and from the graph here, we know that when x equals to 0.2, our potential energy is equals to 1 joule. Okay, so the answer is B. Okay, questions number 18. A block of the mass 100 gram is suspended from the vertical helix spring of the spring constant K, 20 Newton per meter. The block is pulled at a distance of 2 cm from its equilibrium positions of x equals to 0. Okay, determine the period of the oscillation. Okay, so this is actually, we want to find the period for the spring, where the equation for period of the spring is equals to 2 pi square root m over spring constant. Okay, so we substitute into the equation where m is 100 grams, so we convert it into kg, and the spring constant is equal to 20 Newton per meter. Okay, so when you substitute into the equation, you will find that the period of the oscillation is equal to 0.44 seconds. So the answer is B. Okay, next questions number 19. Okay, questions number 19 is chapter 10, okay, where chapter 10 we have 5 questions. So this is the graph. The first one is y versus t, the second one is y versus x. Okay, so determine the wave propagation velocity. Wave propagation velocity equation is equal to f lambda. Okay, so from the graph we need to find the value for the frequency and also the wavelength. Okay, so since this is the first graph is y versus t, meaning that the period here is equal to 4. Okay, so one complete oscillation and the period here is equal to 4. Okay, so since t is equal to 4, therefore frequency will be 1 over 4. Okay, and from the second graph, we know that for one complete oscillation, here is actually equal to the wave number, and the wave number here is equal to 5. Okay, because this is 7.5, so this one will be 2.5. So the wavelength here is actually equal to 2.5, and here we have cm. Okay, so the answer is still in cm, so we substitute 2.5 and the answer is equals to 1.25 cm per second. Okay, so the answer here is B. Next question, number 20. The amplitude of the air vibration at a distance of 9 meters from the point sound of the power is 12 milliwatt. And it is equal to 3 cm. Okay, calculate the amplitude of the air vibration at a distance of 5 meters. So we know that the sound intensity, okay, the sound intensity is directly proportional to the amplitude square and inversely proportional to the distance square. Okay, so now the question says when the amplitude is 3 cm, okay, the distance is 9 meters. Okay, so what is the amplitude if the distance is equal to 5 meters? Okay, so we can use ratio to do A1 over A2 square is equal to R2 over R1 because it's inversely proportional. So A1 is 3, A2 we don't know. Okay, square and square we can cancel. Okay, R2 is 5 meters, R1 is 9 meters. Okay, so finally the new amplitude of the air vibration is equals to 5.4 cm because just now 3 cm. So now the outcome, the unit is still in cm. So the answer is C. Okay, next question. Questions 21, still chapter 10. How many antinodes does this standing wave form? So antinodes A, A meaning like other, okay? So antinode is maximum, so we have 1, 2, 3, 4, 5, 6. Okay, so we have 6 antinodes. Okay, so the answer here is equal to B. Questions number 22. This is also chapter 10. Okay, determine the frequency of the third overtone produced by the pipe with the length 34 cm if the pipe is a closed pipe. Okay, so meaning that closed pipe, the fundamental or the first harmonic here is the length is equal to lambda over 4 or lambda is equal to 4L. Okay, this is the first harmonic where the first harmonic is fundamental V over lambda or V over 4L. Okay. Okay, third overtone, okay, because we only have odd frequency, meaning that we have F1, F3, F5, 7 harmonic, and so on. Okay, so first harmonic we call it as fundamental, third harmonic we call it as first overtone, fifth harmonic we call it second overtone, third overtone is actually equal to 7 harmonic. Okay, so we want to find the frequency of the 7 harmonic or third overtone. Therefore, 7 harmonic is equal to 7V over 4L. Okay, so V is given 330 speed of sound over 4L, where L is equal to 0.34 meter. So finally, third overtone or seventh harmonic, the frequency is equal to 1699 Hz. Or the answer is D. D is the nearest answer. Questions number 23. An observer standing at the side of the road hears the horn of a car that is approaching and then move away. So we have two conditions. The first one is approaching. The second one is move away from the observer with a constant speed, 30 meters per second. If F1 and F2 are the respective apparent frequency where the car is approaching and moving away, so F1 is approaching, F2 is moving away, what is the ratio of F2 over F1? So we have two conditions here. The first condition is when the car is approaching to the observer. So when it's approaching, F1 is equal to 330 plus 0 because the observer is not moving. 330 because the car is approaching, so it's negative 30 times the source frequency. So this is our first equation where F1 equals to 330 over 300 times the frequency of the source. So this is our first case. The second case is when the car is moving away from the observer. So when it's moving away, the frequency or the apparent frequency heard by the observer will equal to 330 plus 0 over 330 plus 30 meter per second times the frequency of the source. Therefore, F2 is equal to 330 over 360 times the source frequency. So this is our second equation. And here we have two unknown, F1, Fs, F2, Fs. Okay, so we can find the ratio F2 over F1 because the question asks us to find F2 over F1. So F2 over F1 is equal to 330 over 360 Fs over F1, where F1 is 330 over 300 times the frequency of the source. So since they are same, so we can cancel 330 and 330 we can cancel. So finally, F2 over F1 is equal to 300 over 360. Okay, so the ratio that we will get is 0.83. Answer is B. Next question, questions number 24. Okay, questions number 24 is a 3 meter iron rod with a cross-sectional area 1 cm square. Okay, so 1 cm square you need to convert into meter square, where cm is -2, but because of square it becomes -4. Extended by 0.5 mm when 250 kg mass is suspended from one of its ends. So what is the Young modulus of the rod? Okay, Young modulus is equal to stress over strain. Okay, where stress is F over A, strain is elongation over original length. So now we want to find Young modulus. Okay, we just substitute where F is the weight, mg. Okay, m is 250 times 9.81. Area is 1 cm squared, or we can write it as 1 exponent -4 meter squared. Okay, elongation is extended by 0.5 millimeter, so 0.5 millimeter, and the original length is 3 meter. Okay, so if you press calculator, the final answer that we will get is equal to 1.47 exponent +11, and the unit is Pascal. So the answer is A. Next, we go to questions number 25, where questions number 25 is actually chapter 12. Okay, how many heat flow through the sheet of the copper where the area is 1.2 meter times 0.8 meter, thickness is 3 millimeter, and the time taken is 1 hour. Okay, if the temperature of the surface are 30 degrees Celsius and 28 degrees Celsius respectively, okay, and they give you the thermal conductivity 401. So now we want to find how much heat, meaning that we want to find Q. Okay, so from the equation, dq over dt equals to -Ka dt over dx. Okay, so we substitute all the value. Q, or the heat, is the value that we want to find. Time is 1 hour. So 1 hour equals to 60 minutes times 60 seconds. Minus thermal conductivity 401. Area is 1.2 times 0.8. And the temperature is from 30 to 28. So we take final 28 minus initial 30 over the thickness is 3 millimeter. Okay, so the final answer for the heat flow through the copper is equals to 9.24 exponent positive 8 joule. Okay, so the answer here is equals to 8. Next question is number 26. A 200 cm3 glass cylinder is filled with the brim with the mercury at 27 degrees Celsius. Okay, calculate the amount of overflow when the temperature is increased to 100 degrees Celsius. Okay, so meaning that initially it's 27 and the temperature will increase to 100 degrees Celsius, so meaning that there is an expansion. So the linear expansion of the glass and the mercury is 4 exponent negative 6 and 6 exponent negative 5. So calculate what is the amount of overflow. So here before we want to find the amount of overflow, we need to find what is the volume for the expansion or for the glass and also mercury first. So V glass is equals to V naught 1 plus gamma delta T, where the initial of course is 200 cm3. 1 plus gamma, okay, so gamma, because it's only give you the linear expansion, they give you alpha. So what is the relationship between gamma and also alpha? Okay, gamma is the volume expansion. Alpha is the linear expansion, where gamma is actually equals to 3 alpha. Okay, so here you must times 3 alpha for the glass. So it's 4 exponent negative 6. And the temperature changes is 100 minus 27. Okay, so if you press calculator, V glass, V the volume expanded from 200 meter cube become 200.1848 meter cm cube. Next, we want to find the volume expansion for mercury. Initial volume is 200 times 1 plus gamma. Again, gamma they give you is only linear, so you must times 3. 3 times the gamma times the linear expansion, 6 exponent negative 5 times the change of the temperature, so it's 100 minus 27. Therefore, the final volume of the mercury is equals to 202.772 cm3. Okay, so the amount of overflow actually is equals to V mercury minus V glass. Okay, so we will take 202.772 minus 200.1848. So finally, the amount of overflow is equals to 2.5872 cm3. Okay, so the answer is donkey. Next question is number 27. The molar mass of the oxygen is 32 grams per mole, and the root mean square of the velocity is of the oxygen molecule at. Okay, calculate the VRMS of the oxygen molecule at 30 degrees Celsius. Okay, so what are the informations we have here? Okay, we have the molar mass and also we have the value for the temperature. Okay, so now we want to find VRMS. Where VRMS, we have two equations. Either you can use 3RT over mass or 3KT over mass. Okay, so this is actually molar mass. Molar mass. Okay, so since we have molar mass, so we 32 grams, so we can substitute 3R. T is 30 degrees Celsius, so it's 273.15 plus 30 degree over M. M is molar mass, so it's in 32 grams. We need to convert into kg, so I will convert 0.032. Okay, so the final answer for the VRMS will be equals to 485.9 meter per second. So the answer is C. Question number 28. Calculate the internal energy of 16 grams oxygen at 30 degrees Celsius, and it's given the molar mass of the oxygen is 32 grams per mole. Okay, so now we want to calculate the internal energy. Okay, where internal energy equation is equals to F over 2 nRT. Okay, so since this is an oxygen F is equals to 5 because it is equals to oxygen is equals to 3 atomic. So I substitute here 3 atomic 5 over 2 and we don't know, but we can use mass per molar mass to find. Okay, mass per molar mass. So we can find mole equals to mass per molar mass, where mass is 16, molar mass is 32. Okay, so we substitute into the equations where we have 16 over 32, and then the value for R is 8.31, and finally the change of the temperature is equals to 30 plus 273.15. So the internal energy is equals to 3.15 exponent 3 joule. Answer is B. Okay, last two questions. The system goes to the state 1 from state 2, okay, meaning that from 1 to 2. It can take half level A, B, C, D. Yeah? The changes in the internal energy of the system is, okay, so as long as 1 to 2, okay, it doesn't matter you want to go straight away, or you want to pass through A, or you want to pass through C, okay? So now, we want to ask, the change in the internal energy of the system is same on all half, okay? Meaning that, as long as the initial is 1, final is 2, okay? How long you go or how near you go, the answer that we will get is actually same, okay? Because we will consider only the initial and the final point, where we start from 1 and we go to 2. Okay, so the answer is D. Number 30. Okay, the last questions. 3 moles of the ideal gas expand 15 cm3 to 100 cm3 at constant temperature of 30 degrees Celsius. Calculate the heat transfer to the surrounding by this process. Okay, so now we want to find the heat transfer, where we want to find Q. Q equals to change of the internal energy plus work done. Okay, so since the question say constant temperature, okay, so constant temperature T equals to 0, the changes, no changes, therefore our internal energy will also equal to 0. Okay, so here internal energy is equal to 0. Therefore, Q will equal to work done. Okay, so work done, because we have the, because this is a isothermal because it's constant temperature. So isothermal work done, we have two. The first one is nRT ln V2 over V1, or equals to nRT ln P1 over P2. Okay, so since we have the volume, so we use the first equation where it's equals to nRT ln V2 over V1. Okay, so we substitute n is 3 mole, R is 8.31, is equals to 273.15 plus 30 degree, ln V2 meaning the final 120 over 50. Okay, so later the final answer that we will get is equals to 6.613 exponent positive 3 joule. Okay, so that's all for pre-PSPM step 1. Okay, hope you enjoy it. Okay, please watch on the next video. I will continue discuss on the pre-PSPM question set 2. Okay, see you. Bye.